This is like back to the drawing board. We talked about smart glass, smart thermostats, green roofs, and various other things for buildings to reduce energy consumption. But here it is insulation, which is all about reducing the loss of energy and thus the reducing energy consumption and emissions. Most houses tend to lose heat or lose the cool air and take heat from outside because of the various leaks and lack of proper insulation. This is especially a problem in cold countries or where there is a strong seasonal cycle. So there are active and passive insulation methods. Here by 2050 it's ranked at number 31 with a reduced CO2 of 8.27 gigatons by 2050 at a net cost of $3.66 trillion and net savings of $2.51 trillion. So good investment overall. Insulation is of course not new. We looked at something like this Tortwalk or whatever it was called, turf roof. Villagers and farmers in the north have been using turf roofs for 1,000 years, from the time of the Vikings as far as we know. This one is located in Gjove village of Faroe Islands, a small archipelago located in the Atlantic Ocean between Iceland and Norway, with an average temperature of 53 degrees Fahrenheit during the warm season. You can imagine how nice and cool it is during the winter. From this paper I picked this up in terms of trend of the European energy demand in the residential sector by energy use. We are looking at million tons of oil equivalent here. Electric appliances, lighting, surprisingly a small portion, water heating, cooking and cooling. But it's the heating. Of course it depends on the latitude and the climate, but in a country like India or the tropical countries it would be reversed, where cooling would take most of it and no heating actually over much of the tropics, except in the Himalayan foothills and high altitudes and so on. So heating is the main concern here. This is from the Penn State Education website, which looks at heating costs for different types of windows in the US. This estimate is for the US, so it's looking at heating costs in dollars. So if you have single pane clear glass aluminum frame, it's $875. Whereas single pane tinted would reduce already to $650. Double pane clear glass wood and vinyl frame would reduce it further to $600. And this is per year. This is for double pane clear glass low SHGC, low E coating wood vinyl frame. So this is some kind of a rating. What is this SHGC? We'll have to figure that out. I better stop here. And so SHGC is solar heat gain coefficient, which I should have looked up before including the figure, but nonetheless here we are. So it doesn't gain heat from the outside, though reduces the need for cooling, etc. So low E coating and wood vinyl frame. So cooling costs for different windows, same thing here. Again, you can see the drop by just increasing the insulation. The various insulation materials are listed here. I'm not going to go into the details, but I think you've heard of most of these things. Fiberglass, mineral wool, not at all wool, but something that's produced from basalt and other minerals. That's a good insulation material. Cellulose, natural fibers, polystyrene, polysocyanurate, whatever that means. Polyurethane we have heard of, vermiculite and perlite, urea formaldehyde foam, cementitious foam, phenolic foam, and insulation facings. So obviously the choice and so on depend on costs and the weather and overall the design of the house and so on. In the north, they tend to have these attics which need to be insulated, especially because they tend to accumulate heat or cold, and they need to be properly insulated. Not often used, but used as storage in most cases, etc. Retrofitting buildings with insulation is a cost-effective solution for reducing energy required for heating and cooling. If 54% of existing residential and commercial buildings install insulation, 8.3 gigatons of emissions can be avoided at an implementation cost of $3.7 trillion. Over 30 years, though, net savings would be $2.5 trillion. However, insulation measures can last 100 years or more, realizing a lifetime saving in excess of $4.2 trillion. Of course, based on the construction type, the houses may not last that long, but hopefully insulation materials can be recovered and reused. But installation, of course, is a high cost in terms of labor and so on. So building itself has to last long enough to recover the lifetime savings, but that's another consideration for reducing consumption and emission as well, of course.